3-Eye Atlas is still changing, and the latest observations make that clear before we even look at anything else happening in the sky. This isn't a dramatic explosion, a sudden fragmentation, or a headline-grabbing flare. It's something quieter, but in many ways more important, a measurable shift in how the object is behaving close to its nucleus, paired with a stubborn persistence of features that simply refuse to go away. That combination is exactly what keeps astronomers watching, because it suggests an object that is neither settling down nor breaking apart, but actively evolving. The most recent image, captured overnight from southern Italy by Tony Schermato using a 25-centimeter Newtonian telescope, adds another data point to a growing pattern. Compared to earlier nights, the inner coma appears noticeably brighter. This is the compact region closest to the nucleus, where freshly released material dominates the signal. At the same time, the outer coma, which previously showed a more extended greenish glow, looks weaker and less pronounced. That shift matters. If everything were fading uniformly, we could write it off as distance from the sun or changing illumination geometry. But that's not what we're seeing. Instead, activity near the nucleus seems to be intensifying or reorganizing, while material farther out is thinning or dispersing. That kind of change points to something happening at or just below the surface of the object. It suggests that whatever processes are driving the release of gas and dust are not shutting down evenly. Some regions may be becoming more active, while others are losing momentum. In comets born in our own solar system, this kind of behavior is often linked to seasonal effects on the nucleus, rotation bringing different active areas into sunlight, or structural changes as volatile layers are exposed. With an interstellar object like 3-Eye Atlas, we don't yet know how well those familiar explanations apply, which makes every small change more interesting. Just as important as what changed is what didn't. The long, sunward anti-tail is still present. It remains extended, coherent, and aligned near a position angle of about 115 degrees. This feature has now persisted across multiple nights, multiple observers, and different instruments. It has survived changes in brightness, shifts in color balance, and variations in inner coma structure. That persistence is critical. Transient artifacts tend to come and go with processing methods, atmospheric conditions, or viewing angles. A structure that keeps reappearing with the same orientation relative to the nucleus and the sun is almost certainly real. The anti-tail's continued presence reinforces the idea that 3-Eye Atlas is governed by a stable, organized physical process rather than random outbursts. Whatever mechanism is producing that sunward structure is still operating, and it's doing so in a consistent way. That alone sets this object apart from the majority of comets, which usually show tails that evolve smoothly away from the sun and gradually lose definition as activity declines. Here, the geometry refuses to relax into something simple. This contrast between subtle change and stubborn stability has become a defining characteristic of 3-Eye Atlas. The inner regions brighten, the outer envelope fades, yet the overall directional structure remains locked in place. From a scientific perspective, this is exactly the kind of behavior that keeps an object relevant long after the initial excitement fades. It's not just doing one strange thing once, it's continuing to behave in a way that can be tracked, compared, and tested against models night after night. While 3-Eye Atlas continues to deliver usable data, January's other much-anticipated sky event is facing a very different fate. The Quadrantid meteor shower is usually one of the most reliable displays of the year. It's known for sharp, fast meteors and brief but intense peaks that can produce impressive fireballs when conditions are right. On paper, it's a strong shower, and in dark skies it often rewards even casual observers. In 2026, however, the sky simply won't cooperate. The Quadrantids peak on the night of January 2nd into the early hours of January 3rd, right under a full moon. That moonlight will flood the sky with glare, dramatically reducing contrast and erasing most faint meteors before they ever become visible. The shower's intrinsic strength doesn't disappear, but for observers on the ground, much of it will be effectively hidden. That doesn't mean the Quadrantids are completely lost. The brightest meteors, the ones that produce clean, fast streaks or occasional fireballs, can still punch through moonlit skies. The best chance comes just before dawn on January 3rd, when the radiant climbs higher in the sky and the background darkness improves slightly. Looking toward the northern sky, near the handle of the Big Dipper, patient observers might catch a handful of brief flashes. It won't be a storm, and it won't live up to the shower's usual reputation, but sometimes one well-timed fireball is enough to make the effort worthwhile. Still, the contrast between these two sky events is striking. One is a normally dependable annual phenomenon muted by circumstances beyond our control. The other is a rare interstellar visitor that continues to offer new information even as it slowly recedes. The Quadrantids will peak and fade quietly under moonlight, while 3-Eye Atlas keeps changing in ways we can actually measure, analyze, and debate. That contrast highlights something deeper about how we experience the sky. Some events are predictable and repeatable, but vulnerable to conditions like weather and moon phase. Others are unpredictable and rare, unfolding on their own terms and rewarding sustained attention rather than a single night of watching. Right now, 3-Eye Atlas belongs firmly in the second category. As January progresses, the object will continue to fade overall as it moves farther from the sun, but fading does not mean inactivity. Changes in the inner coma, shifts in relative brightness, and the persistence of structured features like the anti-tail all suggest that important physical processes are still underway. Each new image adds context. Each comparison with earlier data helps narrow down what explanations remain viable and which ones fall apart. So this is where January leaves us. A meteor shower diminished by a bright moon, and an interstellar object that refuses to become boring. The brighter inner coma and the persistent sunward structure raise new questions about what's happening near the nucleus right now and how long this organized activity can continue. Is the object settling into a new, stable mode of outgassing, or are we seeing just one phase in a longer, more complex evolution? That's not something a single image can answer, but it's something that becomes clearer as data accumulates. What makes 3-Eye Atlas compelling isn't that it provides easy answers, it's that it consistently challenges expectations in small, measurable ways. It doesn't shout, it whispers. And those whispers are exactly what careful observation is designed to catch. As long as it keeps doing that, it will remain worth watching, long after more familiar sky events have come and gone. If you're following these subtle changes as closely as the bigger headlines, this is the moment to keep paying attention. The story isn't over, and the most revealing chapters are often the quiet ones.